The theme for the World Environment Day held on 5th June 2023 focused on solutions to plastic pollution. The world produces 430 million metric tons of plastic each year, and according to NEMA, Uganda has produced over 12,330 metric tons of petty plastics since 2018. Science has shown that plastic takes more than 100 years to decompose.
And truly, we found out that most of the people are aware that if we do not manage plastic waste well, it can lead to environmental and health issues.
Campaigns to stop further plastic pollution in Uganda have focused on transforming from a throwaway economy to a reuse society. This would include recycling, resorting to plastic alternatives to enable sustainable substitutions, and stopping further production of single-use plastics. In an attempt to develop a sustainable solution, a research team from Makerere University Business School, led by Dr. Susan Watundu, working closely with Dr. Abe Mutumba, accessed research funds raised by government through the Makerere University Research and Innovation Fund. The research was to develop an enzyme to decompose polymers waste. The research started with a survey in Kampala slum areas most affected by plastic waste to justify the need for a lasting solution.
We had to find out if we came up with a solution that we are thinking about in the lab that we can use, that can decompose the plastic in a shorter period, will they be willing to take up this solution? And the answer was yes, up to over 90%.
In a try and error method, soil samples were collected from different areas of Kampala. The soils were subjected to lab tests to determine whether they contain a specific bacteria which has enzymes that can decompose plastic.
We had to pick soils in the swamps, soils in the other cultivable areas, and in different locations.
The first samples we got were 30 samples, and to our disappointment, out of the 30 samples, none of them had the bacteria we needed, hence the enzyme we needed.
Unfortunately, the scientists were running out of reagents used to test the soils for bacteria,
which we had imported from the US, and that was the time of COVID, when we couldn't easily, transport was a bit difficult, and we had no local supplier.
However, they went further to collect 50 more soil samples and were taken through the same procedure and protocols.
We were lucky, and out of the 50 samples, at first it was 4. Then when we improved the testing, they got to 6 samples, had the bacteria we needed.
Having discovered the required bacteria in 6 soil samples, another test was required to establish whether the bacteria that was discovered had the exact enzyme the scientists think is able to decompose plastic.
Remember the first one, we were testing for an enzyme called polymerase, which we didn't find out. So this time we changed to PETase and found the PETase in the 6 samples.
Further investigations were required on the PETase enzyme to establish its DNA.
And we found that that was the exact DNA of the PETase that we needed to do the decomposition of the polymers waste, the caveras and the plastics.
After confirming the exact enzyme, they moved to replicate the process and get enough quantities of it. This required more reagents.
Of course, still we had imported, and we managed to replicate the first DNA-confirmed enzyme, PETase, for decomposing the polymers waste.
The researchers say the amount replicated was too small, but they felt that the results were worth the effort so far.
Out of excitement, we had only divided it into 2. We somehow lost out the first set, but that first set which we lost out, it had started working on a small portion of the polymer we had. It was a small part of the cavera.
The team ran out of reagents to use for further investigation.
So At that point, we said we don't want to lose this. This is what we need to further activate and replicate.
This left unanswered questions like how long it takes for the enzyme to decompose plastic, the rate at which the enzyme can decompose plastic, and whether the enzyme has any side effects. However, the researchers are confident that they are a step closer to arriving at a sustainable solution.
The good news is we got exactly what we needed. The other good news, we at least got preliminary observation that it could actually eat if it is further activated.
And of course, we have to do the replication process also to see how can we sustain this, because our target is to go industrial.
Over $100,000 is needed to complete the research. Patrick Senyondo, NTV.